To begin with, let's quickly look into data structure. What are data structures? A data structure is a way of organizing and storing data in a computer's memory to perform efficient operations on the data. So the idea here is that how well you can structure your data, right? So all these questions are discussed deeply in our other video on arrays. So let's quickly jump into what is linked list. So what is a linked list? How is it different from an array? A linked list is a data structure where elements, which are also called as nodes, are linked together using pointers. There are different types of linked list, which we will also look. So basically linked list doesn't require a contiguous memory for its storage, and it allows for dynamic memory allocation. And unlike arrays, which is the main difference, linked lists have variable size and efficient insertion and deletion operations. But the random access of linked lists are slower when compared to the arrays. So now let's look into some core Viva questions which are dedicated for linked list. So how is a linked list different from an array? We partially looked into it. Let's look again. So memory allocation. Linked list, as we looked into, uses dynamic memory allocation, whereas array uses static memory allocation, right? Because when you declare an array, you specify the size of the array initially. However, linked list, in a linked list, you can add and delete the nodes easily even after creating it. So hence the size linked list can grow or shrink dynamically while arrays have a fixed size. What about the element access? Array elements can be accessed directly using the index, or also called as indices, whereas linked lists require traversal from the head to the node to access specific elements. What are the advantages of linked lists? Dynamic size. Linked list can grow or shrink dynamically as elements are added or removed. Efficient insertion and deletion. Insertion and deletion operation can be performed in constant time by modifying references. We will check the time complexity later. Flexibility. Linked list can be easily manipulated to accommodate changes in the data structure. So what are the types of linked lists? So there are three main types of linked lists. One is singly linked list, where each node has a reference to the next node. Doubly linked list, where each node has reference to the previous as well as the next node. And circular linked list, where the last node points back to the first node. Let's take the example here. So in case of singly list, see each node consists of two things. One is the value itself, and the other will be the pointer to the next node. So in case of singly linked list, you can see that this is the head node, which is the first node, which has the value as 5, and then the pointer is pointing to the next node, and the next node has the value 10, and so on and so forth. If you see the last node, it doesn't point to any other node, right? The pointer here is null. So this is called a singly linked list. In case of doubly linked list, you can see that there are two pointers. In case of head node, there is no previous node, hence the previous is pointing to null, the value is 5, and the next pointer is pointing to another node whose value is 10. So if you can see, there is bidirectional link, which means that first node is linked to the next pointer of the first node is linked to the previous pointer of the second node, right? And so on and so forth. And same thing, you can see that each node you can traverse faster because you know which is the previous node linked to the current node and which is the next node linked to the current node. In case of circular linked list, what happens is that it is similar to the singly linked list. However, if you see the last node, in case of singly linked list, it was null. However, in case of circular linked list, the next pointer of the last node will be pointed to the first node. So this is the example of circular linked list. So there are some other questions on linked list which may be asked in the Viva, and most probably you may also be asked to write a small pseudocode. However, let's just quickly go through them. So the questions could be, how do you insert a node at the beginning of a linked list or in middle of a linked list, right? Or at end of the linked list. So in case of insertion at the beginning of a linked list, create a new node with the desired data, set the next pointer of the new node to point to the current head of the list. Update the head pointer to point to the new node, right? How do you find the length of a linked list? Initialize a variable to 0, traverse the linked list, incrementing the variable by 1 for each node visited. The final value of the variable represents the length of the linked list. So basically you have to have a declare a variable and then increment it each time you visit a node. How to delete a node from linked list? Find the node to be deleted and keep track of its previous node. So basically you require two variables here. Update the next pointer of the previous node to skip the node to be deleted. Free the memory allocated to the node to be deleted. Basically you need to have two pointers. Each point, one first pointer will be pointing to the current node and the other node will be other variable will be pointing to the previous node. Coming to the next question, how can you reverse a linked list? Initialize three pointers, current, previous and next. Traverse the linked list, updating the next pointer of each node to point to the previous node. Update the previous and current pointers accordingly. At the end, update the head pointer to the last node visited, which becomes the new head of the reversed list. Now there will be some questions on the time complexity also. So time complexity of inserting a node at the beginning of a linked list will be O of 1 because you directly know at which place you have to insert and it will be O of 1. Time complexity of deleting a node from linked list is also O of 1. However, in case of searching a node and deleting it will be O of n. So these are some of the questions with respect to the linked list. However, there are other questions on arrays for which you can check the link on the top. If you like the video so far, please like, share and subscribe the channel. Thank you.